We'll start off with Bradley from Julia Hub talking about Julia Backend and how it helps. Well, I won't read the title. The floor is yours.
Thank you. Okay, so yes, my name is Brad Carman. I currently work for Julia Hub. In my past life, I worked for Instron, and this talk is an industrial talk about kind of the work I did at Instron and how I built an app with a Julia backend running a model. And the reason why, the reason why I kind of focus on model-based app development is because building models is not easy. I like to say it's like the most challenging programming that a programmer can do, because a model is solving a system of equations all together at the same time. And if there is a problem, there's no way to get a useful error message like you can get in other types of programming. I'm sure some of you doing very challenging work can argue that maybe that's harder than model-based programming, but it can be very hard, right? So if you build a model and you want to do something with the model, and then you want to package it in an app or something that you can share with someone else, there's a lot of friction that comes from that, the fact that models are so challenging to make. So in the world before Julia, building models is generally done with some kind of modeling application to help you build a model, right? So there's like Modelica, for example, is a tool that helps you with solving those insanely hard to solve differential equations. So the thing is, these tools that are help you build models, they're not full-featured programming language. They're just tools to build models. So if you want to take that model and do something with it, it gets converted to C, or it gets compiled to a binary, and then you can take that and do something with it, right? So that means that there's like this wall that exists between the model and everything that comes after it. And that wall creates some serious friction in being that you lose useful errors. So if what you're doing with the model over here causes an error all the way over there, you're not going to get an error message that says, it's not going to be an error message at all. Probably it's just going to crash the app, right? It's just going to. So I've been extremely frustrated for a long time with that scenario. The other thing that you lose is model context. So what I mean by that is when you're in the modeling application, you'll have a nice schematic of the model that you're working on, and you can click on a component and see what variables it has and say, I want to plot this variable. And as a human, you can interact with it and make sense of it. But after it goes over that wall, it's just C code, and it doesn't know anything about what it's computing. It doesn't know about that component that you want to plot, and therefore you have to make all those decisions up front about what you need to export from the model and what you might want to plot in the end. And so if you are over here developing the app and you realize, oh, I wish I had velocity instead of position, well, you're out of luck. You need to go all the way back to the beginning, make sure you export that, and then you can come all the way back to the app. So that creates a lot of friction. Okay, so this was the world without Julia. This is the world with Julia. So the whole point is there's no more wall. You're working with the model here at the app stage. It's the same backend that you had at the very beginning. You don't lose that context. You don't lose useful errors. And that is game-changing for how productive you can be once you get to the front-end development stage. Okay, so I forgot to mention, so you'll see that it was supposed to be myself and Avinash speaking today. Hopefully you didn't come to see Avinash and you just got me. Originally the plan was we were going to build a model of some really advanced models that Avinash works on. So he builds HVAC models. They're super advanced, and I wanted to make like a cool app that showed off that stuff. But yeah, time escaped us. So instead I made a very simple app of a model of just an active suspension system. So we have a wheel, we have the mass of the car, and then we have a seat. Each of these are just like mass spring dampers, and then there's a force that is acted on the seat to give this like active suspension and a little controller to try to keep the seat from bouncing too much. So I built this model using Modeling Toolkit. If any of you out there need to build a model, something like this, and you don't know about Modeling Toolkit, definitely look into it. It is, essentially Modeling Toolkit replaces that model building application that we would use before. So it's very similar to Modelica. For example, if you ever use that, Modeling Toolkit will be completely natural to you. So anyway, that's my model. It's just these components, they're connected together. That gives me active suspension. So to prepare this model to be in an application, which maybe makes sense if I just go and show you the app real quick so you kind of see what this is all about. So coming from industry, I use Windows, which is, I think, kind of rare in the Julia world. So I built applications using Microsoft technology. So this is an app that's built in C# using WPF. And what you see right now is exactly that. And this app does this. So I just add a simulation, I click run, I get results. And what these results are showing you are the position versus time. So the first line here is the road. So basically this is just a bump. The next line here is the wheel. So this is the wheel going over the bump, and then it kind of wiggles. This is the car frame. It wiggles even more, and then the seat wiggles a lot. So basically the passenger, after he goes over this bump, is really not happy, right? So that's what the app does. And I'll go through now. And let me also explain here. So we have parameters that we can change. So what you just saw was active suspension not working because it's turned off essentially. I can go ahead and turn it on, run this again, and you can see now that the bump is a lot smoother. That's what the active suspension is supposed to be doing for us, right? So that's what this app does. Very simple. So let me go through some boring technical bits about how I got that to work. So I needed to prepare a way for the app to change the parameters and those parameters to get to Modeling Toolkit. So in Modeling Toolkit, the component looks like this, where you define parameters, you define variables, you define equations, and then you assemble an ODE system. And so the parameters are just values. So in Julia, I create a structure that maps to the same set of values that this component has. And what I can do is create a broadcasted dispatched function that maps exactly those values of the struct to the values of the ODE system. And you'll see why I do that in a second. So I have certain parameters for certain components. So there's a road, there's a mass spring damper component that makes the wheel, the car, the seat. And then there's a controller parameters. So I put all those together in one final parent structure. And then I do this broadcasted trick again. So I can send this guy as a list of parameters to the system. So the system is mapping to those parameters. And this is making an ODE problem that I can solve. So this is all Modeling Toolkit differential equation stuff. But this is how I can do it. So I can make a function that I send the parameters to, and I get results out of. That's simple as that. Okay. So how do we do this once we go to the front-end C# code? So I have a package that I've made. I haven't published it yet. Just exists as code at the moment. Julia to C# that allows you to take those structures So the road parameters, controller parameters, system parameters, and generate C# that maps them to the Julia structures. And then I can also take the methods that I made in the Julia code and map them to C# so that I can call them in the Julia backend without having to write a bunch of wrapper code. So this writes the wrapper code for you, okay? So a little bit of details of how that looks. So if I generate this road parameter structure, it's going to generate an initializer for me in the C#. I'm going to be sending this the pointer that I get from Julia. It's going to put that it's going to protect against garbage collection, because if I'm going to hold onto that pointer in the front end, I need to make sure that Julia doesn't delete it from me. And then I can take that pointer and marshal it to a structure that I define in C, which matches the structure that's in Julia. And this all works somehow, but it works because the structures that are defined in Julia are type-based, right? So I can make sure that I just match the same types in C#, and it works. Okay, enough with the technical bits. Yeah, so how do I get that pointer in the first place? So when you embed Julia in C#, you essentially have this JL eval string function, and you can use that to call the Julia. That's one of the ways to interface with the Julia backend, right? So I can call that, and I can get a pointer to an empty structure of the system parameter structure. So then I send that pointer to the thing I was just showing you, and that populates that structure in the C# world. And then I can do something as simple as do show parameters, which calls this function I made in Julia that's as simple as this, which is saying display the parameters. And it works. It will print out the parameters to the standard output. And so in my C# app, I can just have the console showing as well, and that's where I can capture all that output. All right, so how do you embed Julia in C#? What you need to do is call this JL init with image. And where that comes from is from libjulia.dll. So if you were doing this in C, it's a lot easier because you just need to include the header file, the julia.h file, and then you get these functions for free. In C#, you need to do DLL import, and then you need to make sure you match the signature of the function as it would be in the header file. So you launch your C# process, and then you call JL init with image, and then you have the Julia backend running inside of that process. So they're sharing memory. And you just need to give it the technical bits of where's the Julia executable, where's the system image, and then where is your load and depot path. And the system image, by the way, right now I'm just running the standard image. But when you're ready to deploy this, you can use package compiler, generate your system image with all of your code already compiled, and then you can ship that system image and point to that. Okay, so yeah, getting back to getting rid of that friction, why this is so cool to be able to do this. So here's an example of a useful error. So in the Julia code, in my module, I have a set property set for this mass spring damper. If the mass is below 0, it's going to give an error, right? So very simple thing. But this is the kind of thing that before Julia, if you did this, you don't get a useful error. It just crashes the model, right? And you might spend half a day trying to figure out like what the heck is going on. But now, if I try to enter in a negative mass, I will get the error message that was coming from Julia directly. Comes all propagated all the way up to the application. And then model context. So what I'm demonstrating here is that I can enter in whatever variable I want to plot at any point in time. So I'm doing this as the application's running. I can actually ask for a different variable than I intended to have in the very beginning. So yeah, I think that's enough said. It just works, basically, is the really cool thing. And one other really cool thing that you can do is you can actually run revise. So if you're building a very complex application and you're trying to sort out what's happening on the front end and you need to make changes in the back end, you can actually make revise happen. So I'm just showing an example here that I forgot to include gravity in my equations of the model. I could see that the truck is taking off instead of staying on the ground. And I can go ahead and fix it. So you just need to make sure you run revise when you launch the app. You fix the code. This is some bit that I don't truly understand. When you're embedding Julia, you don't have the REPL running, so there isn't this thread in the background. And revise is a little different when you do this, so you have to manually call it. But it works. And as you can see, I changed my code. I left the app running the entire time. I never closed it. And Julia did its thing. It revised, and then I ran and got the right result. So that's something that's very, very cool. So I only have 5 minutes left, so let me just pause for questions now. See if anybody wants me to say anything. Yes.
So that C# code that's generated, you save that, or
Yes.
is it generated every time you run the executable again and then insert it? So if you change the Julia struct, for example, you need to actively change your C# code.
Yes.
So that needs to stay in sync.
Yes.
Manually.
Exactly right. Exactly
Okay.
right.
Yeah.
So I have a code gen script that I just have in my module. So if I update my Julia code, then I just need to remember to run that code gen. But then you just do it once and you're done. Yeah.
Any more questions?
So there are already GUI frameworks in Julia like GTK and QML. What were your reasons why you chose C# to building the GUI?
Partly it's just because I know it.
Yeah.
But I've also played with these other. It would be nice to just do everything in Julia, right? But they're not as mature as WPF is extremely powerful. So they've been developing this front end technology for a long, long time, and you have nice coding patterns, and you can do some really powerful things. So, yeah, I'm looking forward to Julia getting to that point when we.
Yep, nice talk.
Thank you.
I have a question to the structure I saw in C#, if I understood correctly. So, for example, if you put there double char double, and you now have two compilers included, a Julia compiler and a C# compiler, what if one of them thinks to add 7 empty bytes behind the char? So the alignment of the memory, does one need to be careful there maybe? Or you didn't, nothing happened, everything was fine?
In theory, the structures, part of what I've done my best, and I'm not an expert in this stuff, but I did my best in this package to ensure that that doesn't happen, right? That the structures will line up and the memory will line up. There are sure edge cases I have failed to do correctly, but I have done lots of strings and vectors and numbers and then complex structures inside of structures and structures, and it all works so far.
Okay.
Yeah, so.
Okay, thank you.
Yeah. So here's the codes. If you're all interested, please check it out. Please help contribute if you find this interesting. I'd be happy. Yes.
As far as I know, creating the sys image is very important for these presentations.
Yeah.
So the package that depends on the binary builders that works well with creating that that packages works well with when creating the sys image.
So your question is,
Yeah,
when
that's-
generating the
yeah,
system image?
Yeah. There's some package that depends on the binary builders, right? Some libraries made by static flows. So
The thing is, I'm not sure the binary building has anything to do with this particular path, because building a system image is there's really no difference. It's just, in this case, pre-compilation happened, and all that pre-compiled Julia code went to some folder. Package compiler just puts that all in the system image, is my very simple way of seeing it. So it will work. You just do package compiler, and then you don't need to include all. Yeah, and then you can just ship that, and it should just work. Yeah.
okay, thank you.
Yeah. Oops.
Maybe time for another question if there's any.
And I feel your pain about the size. Yeah, because the system image can be quite large. The one I was generating before was 1.2 gigabytes was the size it got to. So
There was a nice talk at last year's local JuliaCon by Jeff about the binary sizes, but I'm not sure how. He said they can get them way down, but I'm not sure how easy it is and how there were some risks involved.
yeah, yeah. Unfortunately, it doesn't sound easy, but
Okay, then let's thank. I was going to say again, we didn't thank you before.
thank you.
And then you're up.